I want you to picture a war zone. Seriously, if you can, just close your eyes for a second and imagine what that looks like.
I'm guessing most people go straight to the explosions, right?
Oh, totally. I mean, if you're like most people, your mind immediately goes to that cinematic imagery. You know, you're picturing fighter jets roaring through the sky, dropping payloads.
That heavy action.
Yeah, you're seeing these massive, heavily armored tanks charging across open fields. You're hearing the dramatic explosions, the crossfire, the sheer overwhelming chaos of it all.
It's all fire and fury.
Exactly. It's the narrative we're the most familiar with. But the reality is, all those multi-million-dollar fighter jets, the highly trained troops, the unstoppable tanks.
It's completely useless.
Literally useless without the runways, the roads, the bridges, and the concrete beneath them. So today, we are pulling our focus away from the explosions.
Which is a very necessary shift.
Yeah, we are taking a deep dive into a concept called the invisible architecture of warfare. And this is all based on some incredible insights from a text we've been looking at called Architects of War, the Strategic Power of Military Engineering.
It's a fantastic source. Really eye-opening.
Okay, let's unpack this, because we are about to completely dismantle the Hollywood illusion of how battles are actually won.
I think this is a crucial paradigm shift, for anyone interested in strategy. The core thesis of the source material is that our understanding of weapons and tactics is fundamentally incomplete if we don't understand the infrastructure that allows those weapons to function.
Right, the foundation of it all.
Exactly. I want to invite you, the listener, to reconsider the battlefield. Because the quiet truth is that engineers dictate the physical reality of a conflict long before the first shot is even fired.
It really changes how you look at every historical conflict. And to truly understand why infrastructure matters more than firepower, we have to look at the mechanics of momentum.
Momentum is everything.
It is, and the text outlines this hypothetical scenario that just perfectly illustrates it. Imagine you are commanding a massive mechanized division.
And just to clarify that term for a second, a mechanized division means you aren't just commanding troops on foot.
Right. You are moving a heavy, fuel-guzzling convoy of tanks, armored personnel carriers, and mobile artillery.
It's a lot of metal.
So much metal. You're advancing rapidly toward enemy territory. Your intelligence is perfect. Morale is high. You have overwhelming firepower. You are an absolute juggernaut.
An unstoppable force.
Right. But then you roll up to a major river, and the only bridge across it has been completely destroyed.
And at that exact moment, the currency of the battlefield shifts entirely.
It shifts from firepower to time, right?
Yes. The offensive just stops.
Yeah.
All of that forward momentum vanishes into thin air.
It's like owning a multi-million-dollar top-of-the-line sports car. You have this V12 engine. You can go 0 to 60 in 2 seconds. You are revving the engine.
But you are permanently stuck behind a massive pothole.
Exactly. A massive, inescapable pothole on a one-lane dirt road. All of that horsepower is instantly rendered completely useless until that pothole is filled.
And strategically, the implications of that pothole are catastrophic. Because when your offensive stops due to a blown bridge, the enemy isn't just sitting on the other side of the river waiting for you to find a detour.
They're actively using that time.
Right. They're using that gifted time to fortify their defenses. They're bringing in reinforcements. They are setting up anti-aircraft batteries to deny you the airspace.
So a campaign that looked totally unstoppable on paper begins to lose all its operational tempo.
Simply because they were stopped by the geography, not by enemy fire.
But then the text introduces the countermeasure. Our sports car is blocked, but suddenly a military engineering unit arrives at the riverbank.
And they aren't carrying rifles.
No, they are driving these massive trucks equipped with mobile bridge systems. And we aren't just talking about, wooden planks here.
Oh, definitely not.
These are hydraulic, scissor-folding metal structures that launch straight off the chassis of a tank. They unfold across the gap, lock into place, and create a reinforced span capable of supporting a 70-ton main battle tank.
What's fascinating here is how engineering isn't just a support role in the background. It actually dictates the speed and tempo of the entire war.
Because within hours of that bridge unfolding, those 70-ton tanks are crossing the river.
The supply trucks resume their movement.
The engineers are quite literally stepping on the gas pedal for the whole army. So if momentum is the ultimate prize in warfare, the people controlling the roads are essentially controlling time.
And according to the source material, they do that by manipulating space.
Right. The text breaks this down into 3 fundamental engineering missions.
Yeah, and these 3 pillars represent a very systematic approach to controlling the physical board, so to speak.
So the first mission is mobility. which, I mean, this is probably the easiest one to grasp.
Keeping your forces moving.
Exactly. Your job is to keep your own forces moving freely across difficult terrain. You are grading roads, repairing highways, throwing down those temporary hydraulic bridges.
Clearing minefields, too.
Right. Driving those specialized vehicles with the massive flails to safely detonate explosives. It's all about speed, because every single hour saved in transit is an hour the enemy doesn't have to prepare.
Mobility ensures your forces have absolute freedom of movement. But the second mission operates on the exact opposite principle.
Right, counter-mobility. And I have to say, when I first read this section, it felt completely counterintuitive to the whole concept of engineering.
How so?
Well, wait, so engineering isn't just about building things up, because we usually think of engineers as builders, people who create solutions, but counter-mobility is about deliberately destroying infrastructure to shape the enemy's decisions.
It does sound like an oxymoron, I'll give you that.
Yeah.
But in warfare, destroying infrastructure is a highly calculated, highly technical skill.
It's not just randomly blowing things up.
Exactly.
Yep.
Counter-mobility is entirely about working against the enemy's momentum. It is the tactical application of friction.
Friction, meaning you are purposefully creating that pothole that stops their sports car.
Precisely. Let's look at the mechanics of an anti-tank sitch, for example.
Okay.
It's not just a random hole in the ground. It is a carefully calculated geometric trap, usually dug in a very specific V shape or U shape.
Right, so when an enemy tank tries to cross it,
The front treads hit the steep opposite wall, the tank dips forward, and the main gun barrel literally digs straight into the dirt.
oh!
Yeah, the tank becomes physically wedged and immobilized.
So by building that ditch or by, blowing up a specific highway overpass, you are forcing the enemy to look at a map and choose a completely different route.
You're denying them the fast paved roads.
And forcing them into a muddy valley where they have to move at like 5 miles an hour.
You are essentially designing a maze.
Designing a maze, I love that.
You are forcing the enemy to walk exactly where you want them to walk, usually right into an area where your forces have the tactical advantage. You are shaping their decisions and their physical location before the combat even begins.
Designing a maze. That really highlights the psychological aspect of altering geography. Okay, so we have mobility to keep your troops moving and counter-mobility to trap the enemy in a maze.
Which brings us to the third pillar.
Survivability. Now, when I hear survivability, my mind immediately jumps to World War I.
Trenches and mud.
Exactly. Soldiers with shovels digging muddy trenches to hide from artillery fire. But the text makes it clear that this mission has evolved way beyond just digging a hole.
Oh, drastically. The advent of precision-guided weapons completely revolutionized what it means to survive on a modern battlefield.
Because you can't just hide in a ditch anymore.
Right, you can no longer rely on a simple trench when a satellite-guided missile can literally be directed through a specific ventilation shaft from hundreds of miles away.
The threat environment has changed the fundamental geometry of protection.
It really has. Today, survivability engineering means constructing deeply buried underground command centers reinforced with advanced composite materials.
Hardened aircraft shelters too, right?
Yes, shelters that can withstand direct kinetic impacts. It also involves incredibly complex camouflage and deception systems designed to hide entire facilities from thermal imaging and radar.
And there was one detail in the source that really reframed this whole pillar for me. Engineers aren't just pouring concrete to protect human bodies anymore.
They're protecting the data.
Right. They are now tasked with protecting data centers and communication networks.
That is a vital evolution. In modern warfare, we talk a lot about situational awareness.
Meaning the ability to know exactly where you are or where the enemy is.
Exactly, and what's happening over the horizon. But that awareness is entirely dependent on digital networks.
So if a missile takes out your primary server rack, your army basically goes blind and deaf.
Yes.
Oh.
Protecting a cloud server is now treated with the exact same level of urgency as protecting a physical bunker.
Which is wild to think about. Now, the need to protect a data center is obviously a very modern problem.
Sure.
But this core philosophy, this idea of military engineers quietly shaping world events through construction, that goes back centuries.
Oh, definitely. The tools change dramatically, but the strategic imperative remains exactly the same throughout human history.
Right, because this massive logistical challenge didn't just appear with the invention of the microchip. And the text brings up the Roman Empire, which is the classic historical example here.
The ultimate road builders.
Yeah. We always hear about the Roman legions, their discipline, their armor, their battle formations. But the sources point out that the Roman Empire actually expanded and held its territory, specifically because their engineers built this unprecedented network of stone roads.
The Roman road network was the ultimate mobility multiplier of the ancient world. And the engineering behind them was incredibly sophisticated.
They didn't just clear a dirt path.
No, they dug deep trenches, layered them with sand, gravel, and stone blocks, and engineered them with crowns for water drainage.
Which meant that while adversary tribes were slogging through knee-deep mud after a rainstorm, a Roman legion could march across the empire on dry, flat stone.
At a speed their enemies simply could not match.
Here's where it gets really interesting, though. If you fast forward from the Roman era to 1944, you see the Allies facing the exact same geometric and logistical problems.
During the invasion of Normandy.
Exactly. World War II. When we think of D-Day, we naturally focus on the sheer, terrifying bravery of the soldiers storming the beaches.
And that bravery was absolutely essential. But capturing the beach was only the first half of the equation.
Because once you take the beach, you have a massive physics problem on your hands. You now have hundreds of thousands of troops in France.
And they need supplies.
They need food, they need bullets, medical supplies, and thousands of gallons of fuel. But the Allies hadn't captured a major French port.
Right, and you cannot unload a 30-ton Sherman tank or a massive cargo ship onto a shallow, shifting sandbar.
Especially since the English Channel tides are notoriously volatile. So what do? Because they couldn't capture a port, the military engineers simply built one and brought it with them.
The artificial mulberry harbors.
Yes. The scale of this is just mind-blowing. They prefabricated these massive hollow concrete blocks in Britain. They called them caissons.
And these things were massive.
They were the size of 6-story apartment buildings. The engineers literally towed these concrete behemoths across the rough English Channel using tugboats.
It's just an unbelievable logistical feat.
Right. And once they reached the coast of France, they opened these valves, intentionally flooded the hollow concrete blocks, and sank them to the ocean floor in a massive semicircle.
And by sinking those caissons, they instantly created an artificial breakwater. It stopped the violent waves of the channel and created a zone of calm water.
And then they attached miles of floating roadways, which they called whales, that were engineered to rise and fall with the dramatic ocean tides.
Which allowed massive cargo ships to dock in deep water and roll supplies straight onto the beaches of France.
It is one of the most audacious engineering feats in military history. I mean, whether you're looking at the Romans layering stone roads or combat engineers at Normandy secretly dragging an entire harbor across the ocean, the goal is identical.
Restore and control the transportation network immediately.
Victory was determined by the speed of construction just as much as battlefield tactics.
It truly reframes history. But it also sets the stage for the present day. Because if World War II required dragging an artificial harbor across the ocean just to keep the momentum going.
We really have to look at how that scales today.
Exactly.
Because we are no longer just dealing with concrete and steel, right?
Yeah.
We are steeped in digital technology. The fundamental missions, mobility, counter-mobility, survivability, they haven't changed.
But the execution in the modern era is almost unrecognizable. The complexity has scaled exponentially.
Primarily to support the unsung hero of all warfare, which the text highlights heavily, logistics.
Yes.
Let's talk about the mechanics of modern logistics, because an army is basically a giant, hungry organism, and modern military equipment consumes an unbelievable amount of resources.
It really does.
Like, a single Abrams tank doesn't measure its fuel efficiency in miles per gallon. It measures it in gallons per mile.
This is where engineering and logistics completely merge into one ecosystem. Think of the military engineers as the circulatory system of that giant organism.
Okay, the circulatory system.
Right. If the roads collapse under the weight of the supply trucks, the arteries are clogged, the logistics stop.
And if the logistics stop, the combat power disappears within hours. Those incredibly expensive tanks just become stationary metal boxes.
Exactly. And to keep those arteries flowing today, the technology the engineers use is staggering.
The text details some crazy stuff here. Like, fleets of small drones are now deployed ahead of the main force.
Using LiDAR.
Yeah, LiDAR, laser scanning technology, to survey the terrain and map the topography in high-definition 3D before a single human even steps foot in the area.
They can instantly identify which bridges can hold the weight of an armored convoy and which ones will collapse. They are mapping the friction points of the environment in real time.
And it goes way beyond mapping. They even mention the use of 3D printing right at the front lines.
Oh, that's a game changer.
It really is.
Yeah.
Imagine like a titanium gear in a specialized radar vehicle breaks.
Historically, that would be a nightmare.
Right. A requisition order would have to go to a base in another country. The part would be flown to a regional hub, loaded onto a supply convoy, and driven for days through hostile territory.
But today,
a digital file is beamed via satellite to an engineering tent near the front line, and a specialized 3D printer manufactures that exact titanium gear on the spot.
if we connect this to the bigger picture, it proves that the speed of logistics wins wars more than the sheer volume of firepower ever does.
Absolutely. And I want to pause here for a second and ask you, the listener, to think about how this applies outside of a military context.
That's a great point.
Because the text highlights this really beautiful dual use for all of this capability. Think about a massive natural disaster, a catastrophic earthquake or a hurricane.
The infrastructure is totally gone.
Right. The roads are wiped out. The power grid is completely destroyed. The local government is overwhelmed. Who actually goes in to fix that?
It requires the exact same skill set. You need people who specialize in restoring critical infrastructure under chaotic, extreme, and totally unpredictable conditions.
And it's these exact same military engineering units. They deploy to disaster zones, and they act as a massive humanitarian force.
They set up industrial-scale reverse osmosis water purification systems.
So thousands of displaced people have clean drinking water. They repair the power grids. They build temporary bridges so ambulances can get through.
They clear the debris from airport runways so international aid can actually land.
The expertise used to sustain an army in combat is the exact same expertise vital for restoring civilization after a crisis.
It really underscores the fundamental nature of engineering. It's ultimately about solving complex physical problems in the real world, whether the obstacle is an enemy blockade or a collapsed highway overpass.
Which naturally leads us to the most futuristic part of the source material.
The battlefields of tomorrow.
Right, because if engineers are using 3D printers and drone mapping today to rebuild after disasters, what kind of radical tools are they going to be using in future conflicts?
We are on the cusp of a technological shift that will likely redefine the concept of human exposure on a battlefield entirely.
The final section of our text looks ahead, and it details the development of autonomous construction vehicles.
This is wild stuff.
We are talking about massive robotic bulldozers and excavators equipped with AI pathing and environmental sensors.
They can drive themselves into a hot zone.
Yes, and build physical fortifications, like digging those complex anti-tank ditches we talked about earlier, all without a single human operator sitting in the cab.
The human soldiers never have to be exposed to enemy fire while the heavy lifting is done. It is a profound acceleration of time.
And alongside these physical advancements, the text specifically points to a critical shift happening in the invisible realm.
The rise of cyber engineering.
This goes back to protecting the data centers and the networks, right?
Exactly. But it goes deeper than just protecting a server rack. The modern battlefield is becoming one massive, interconnected engineering system.
Because everything is online.
Right. Every drone, every autonomous bulldozer, every logistics software program relies on code.
So protecting the digital infrastructure that controls those machines now holds the exact same strategic weight that protecting a physical bridge held in World War II.
Because if the enemy can hack your autonomous construction vehicles or infect your AI logistics software with a virus,
they've achieved counter-mobility.
Exactly. They have stopped your army without ever dropping a physical bomb. This raises an important question as we look to the future. Who holds the real strategic power? Is it the infantry soldier on the ground, or is it the cyber engineer writing the code and securing the autonomous systems from thousands of miles away?
Wow. So what does this all mean for you listening right now? If we zoom all the way out, the core takeaway is this. The most sophisticated missile systems in the world, the most advanced fighter jets, the bravest soldiers.
They're completely neutralized without secure logistics.
Right. Without reliable runways and resilient infrastructure, victory is never determined solely by weapons. Warfare is a massive, complex structural ecosystem.
And as artificial intelligence, robotics, and cyber capabilities continue to evolve, the organizations that master engineering innovation will dictate exactly how tomorrow's conflicts are fought.
Before a single shot is ever fired.
They are truly the architects of the strategic landscape.
It really changes how you view everything from a local highway repair to global geopolitics. And before we wrap up today, I want to leave you with one final thought to ponder, something that really builds on the future tech we just unpacked. Consider those autonomous bulldozers and the AI drone swarms we just talked about. If artificial intelligence can instantly analyze a terrain's friction points, and robotic swarms can build or destroy complex fortifications in minutes entirely without human intervention,
Right.
could the warfare of the future eliminate the human soldier entirely? Think about it. Future wars might not be fought with human courage at all, but rather as a pure automated construction and demolition match between rival algorithms.
That is a wild thought.
Right. Who needs an army when your buildings can fight for themselves?
Oh, yeah.
Anyway, thank you so much for joining us on this deep dive. Keep questioning those invisible structures around you because there is always an architecture to the chaos. Catch you next time.
Thank you for joining us on this Strategic Vanguard podcast. If you found value in this analysis, don't forget to like, share, and subscribe to our channel. We bring you fresh podcasts every Monday here on YouTube and Rumble, and you can also catch the audio versions on Spotify and Amazon Music. Just search for Strategic Vanguard Podcast. For more insights, articles, and discussions, subscribe to our blog at strategicvanguard.com. Your support helps us grow and bring you more in-depth analysis on defense, geopolitics, and strategy. Until next time, stay informed, stay strategic.